The next one is electron affinity. Electron affinity is the amount of energy released when one or more electrons are added to the outermost shell of an isolated atom. The amount of energy released when one or more electrons are added to the outermost shell of an isolated atom. So we have to discuss the electron affinity along the group and along the period. Before we start with the discussion with period and group, you should know that it is the amount of energy released when one or more electrons are added. When we add electron, then only energy is released. So to which elements or which atoms we can add electron? The element which accept electron, there we can add electron, yes or no? So which elements or atoms accept electrons? Non-metals will accept electrons, yes or no? So if non-metals are accepting electrons, then the energy released by the non-metals is more than the energy released by metals, because metals will not accept electrons, correct or no? So this electron affinity is depending on amount of energy released when we add electron to an outermost shell of an atom. Okay, so the first one in electron affinity is along period, correct? So what happens to the electron affinity along period? So as we move from left to right along period in a periodic table, the nuclear charge increases and the nuclear attraction increases, and hence the electrons can be added to the outermost shell of an atom, and therefore the electron affinity increases, correct or no? Electron affinity increases. Why electron affinity increases? Because we can easily add the electron to the outermost shell. So if we are adding electron to the outermost shell, then energy release will be more, correct or no? Take an example along third period. You take, if you are taking a third period, the first element along the third period is sodium. This is 11. So what is its electronic configuration? 2, 8, 1, correct or no? Then the element along the sodium period or the third period, here we take 11, 12, 13, 14, 17. We will take chlorine 17. Then what is its electronic configuration? 2, 8, 7, correct or no? In sodium also there are 3 orbits, and in chlorine also there are 3 orbits, but number of electrons and number of protons are less here and more here, correct or no? So here force of attraction is less, nuclear attraction is less, here nuclear attraction is more. So if nuclear attraction is less here, this atom will not accept electron, but this atom will accept electron because its nuclear attraction is more. So if it is accepting electron, how many electrons it will accept? One electron it will accept. If it is accepting one electron and this is not accepting any electron, so if this is accepting electron, then it is releasing energy. This is not accepting electron, so this will not release energy. If this is releasing energy, then this electron affinity is more than that of sodium. Okay, so this is along the period. Then B, along group, it is reverse of that of along period. What happens to the nuclear charge? Nuclear charge may be more, but the number of orbits increases along group, and the nuclear attraction decreases and hence the electrons cannot be added to the outermost shell, not be added easily, and the electron affinity decreases. Correct or no? Electron affinity decreases because as we move down the group, suppose this is the first atom in a group, then as we move down the group, the size of atom goes on increasing or no? Size of atom increases, correct? If size of atom increases, then the nuclear force or the nuclear attraction decreases. If the attraction is decreasing, the atom will not accept electron if that nuclear attraction is less, correct or no? So if the atom is not accepting any electron easily, then it will not release energy, and due to which electron affinity decreases. Okay.